This is a tutorial to show how to use Excel to construct a calibration curve, to use Linest, and determine the 95% confidence level, and then applying the corresponding error bars in the graph that's generated. This data is taken from the Harris Quantitative Analysis textbook, page 87. In this particular example, we have an absorbance data in which the different amount of proteins are determined. The data shows the absorbance of 3 trials with samples ranging from 0 to 25 microliters. So in the first part of this particular tutorial, we are going to do the corrected absorbance. In order to do the corrected absorbance, we're going to have to take the absorbance reading and subtract the 0 or the blank sample. In this particular case, we're going to take these independent readings, take the average of it, and then use this average to correct for all the other absorbance reading. Now, in order to have Excel choose this reading right here, we're going to put a $sign so that the cell doesn't move when we apply the automated calculation. So I'm going to calculate the rest of these. Then I'm also going to, if you notice the equation over here, this corrected absorbance is for this absorbance minus this correction, and this corrected absorbance is for this absorbance minus this correction, and so on and so forth. So we're just going to apply this whole array for the for all these calculations. Oops, I forgot a point over here. This was 0.392. I need to include that as well. So let me go ahead and finish calculating these. Then I'm going to take the average of these absorbance. I'm going to change the number of significant figures for these numbers right here by using this, and also apply it to the average. Now I'm going to take the I'm going to plot the data by highlighting this and then pressing on the command button and highlighting that. And I'm going to click on the scattered. You can see that that is what the graph looks like. I'm going to go ahead and finish this, and this is my XY plot. It's my calibration curve. I'm just going to delete that. I'm going to change the color of the points. And then I'm going to add a trend line. It's going to be a linear equation, and I'm going to show the equation and the correlation factor. And this is the equation for the line. I'm going to go ahead and increase the size of that font. That's the equation of the line. Now the next thing I'm going to do is I'm going to do a linear regression with this by using Linest. Linest allows a calculation of the linear allows you to do a linear regression, and it also calculates the standard deviation for the slope as well as the standard deviation for the y-intercept. To do Linest, you need to figure out what data points you're going to be using. I'm just going to make this 0 and type in the equation. I'm going to click on this cell because this is where my output's going to be. I'm going to hit equals Linest. If I don't know that function, I could just look it up here, and then the program will prompt me for some of the data. The data is going to be, first I do my y values. There should be a parenthesis here, followed by a comma. The x values are these: true, true, and then we'll hit return. Now it doesn't show the whole output here, so what you need to do is you need to highlight all these cells, this 2x3 cell, go back to the formula bar, and then press Command and hit return again. And that right there is how to use Linest to generate the parameters for the linear regression. You can see that the slope 0.0158 is the same as the one that we did when we added a trend line. The intercept is 0.00815, and that's certainly close to this right here. If I want to change the number of significant figures in my equation on my graph, I just double click here, and then if I go to numbers, I can change that to scientific notation and indicate the number of significant figures, and there is the equation with more significant figures. Let me just change the background, and change that fill color yellow, and there it is. The next step is to use to add error bars in the linear equations shown, and to do that I'm going to use the example that is on page 90 in your textbook. On page 90, however, they don't use this mean absorption, that is the average of these 3 independent studies. They actually that is, they don't apply the corrected absorbance. They just take the average of these and they use that in their calculation. So I'm going to go ahead and do that. Insert a column here, and then I'm just going to take the average of these 3 right here. And these numbers should be the same as that on figure 8.16 in your textbook. So this is the mean, and I'll call it mean 2. In this particular example, we're going to do a student T, and the student T will be on the 95% confidence level. So we're going to figure out what that T value is by having Excel calculated for us. So this will be T INV is the function, and it's going to be for the 95% with 2 degrees of freedom. So this is going to be equal to TINV 1 minus 0.95 comma 2 and that's the t-value that we're going to be using. The other thing we want to do for this particular part is figure out the standard deviation. Remember that we're taking the average of these three independent absorbance, so we're going to have a standard deviation for each one of these. So that's just equal to, we're just going to highlight these right here. And that's going to be right here. Now, our confidence interval, our 95% confidence interval, is going to be equal to the t times the standard deviation divided by the square root of the number of samples for each one. And since each one of these have three trials, 1, 2, 3, we're going to divide it by the square root of 3. So that's going to be the equation for this column right here. So I'm just going to say equals the t-value times the standard deviation divided by the square root of 3. Now I also want to make this value right here fixed, so I'm going to put a $ right here, and then I'm going to do a propagation of calculations. So that's going to be the 95% confidence interval based on this mean. Now we're going to generate the error bar for our graph, and we can do that by double clicking on this right here, one of the data points, and then going to the Y error bar, and right here under custom we're going to indicate that it's going to be the 95% confidence interval plus and minus. And here it is. This is the equation that shows the error bar for our measurements. Notice that there's a huge error bar because of this value right here. If we delete that, you can see that the error bar is smaller. We also change the average, but let me just put that back, and that completes our tutorial.